Hi dear students, welcome back to the session. In this class, let us derive an expression for force acting on current carrying conductor in a magnetic field. Next is force on. Which force? Magnetic force. Force on current carrying conductor. Force on current carrying conductor in magnetic field. Force on current carrying conductor in magnetic field. If we consider any conductor in which current is flowing and place that conductor inside the magnetic field, definitely that current carrying wire or current carrying conductor is going to experience which force? Magnetic force. ಇದಕ್ಕಿಂತ ಮುಂಚೆ ಏನು ಡಿಸ್ಕಷನ್ ಮಾಡಿದ್ವಿ ನಾವು? Moving charges are experiencing the force in the magnetic field. ಯಾವಾಗ moving charges are experiencing the force in the magnetic field, definitely if we consider any current carrying wire or current carrying conductor and place that current carrying conductor inside the magnetic field, definitely that conductor is going to experience which force? Magnetic force. Therefore our discussion is we are calculating the force on current carrying conductor which is placed in the magnetic field. Let me consider here. So imagine that this is the direction of what? The magnetic field. This is the direction of the magnetic field in which I am placing a conductor of length L. This is the conductor of length L. L is a length of a conductor. L is a length of a conductor and A is called, capital A is called area of cross section of a conductor. Concentrate on the terms here. Length of a conductor is L. Length of a conductor is L and area of cross section of a conductor is A, and this conductor is placed in magnetic field B in such a way that its orientation or its length of a conductor makes an angle theta with the direction of the magnet. So in this conductor, of course, the current is flowing. Let I is a current which is flowing through a conductor. This current carrying conductor is placed in the magnetic field. As per our discussion, the force is acting on this conductor. We are deriving an expression for the force. My next question is, what makes this conductor to experience a force? If force act agಲಿಕ್ಕೆ reason ಏನು? ಈ ಕಂಡಕ್ಟರ್ ಮೇಲೆ ಯಾಕೆ ಫೋರ್ಸ್ ಆಕ್ಟ್ ಆಗುತ್ತೆ ಹೇಳಿ? What is current carrying conductor? So current carrying conductor is nothing but what? Group of flowing charges, group of moving charges. ಅಂದ್ರೆ ಕರೆಂಟ್ ಫ್ಲೋ ಆಗಬೇಕಂದ್ರೆ ಕಂಡಕ್ಟರ್ ನಲ್ಲಿ ಡೆಫಿನೆಟ್ಲಿ ದೇರ್ ಶುಡ್ ಬಿ ಅ ವಾಟ್? Motion of charges. Already we know very well, when the charge is moving in a magnetic field, it is experiencing the force. Of course, charge is moving in a magnetic field, it is experiencing the force. Then what is the total force acting on a conductor? Total force acting on a conductor is equals to total force acting on all the charges which are flowing in a conductor. All the charges which are flowing in a conductor. Total force acting on all the charges which are flowing in a conductor is the force acting in a conductor. And in calculate ಮಾಡಬೇಕು ಹೇಳಿ ನಾವು? We have to calculate what is the net force acting on all the charges which are flowing in a conductor. Which charges flowing in a conductor here? Which type of charge is flowing in a conductor? Electron. Then what you have to calculate? Calculate total force on. Calculate total force on all the moving electron in a conductor. ಈ ಕಂಡಕ್ಟರ್ ಎಷ್ಟು ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಮೂವ್ ಆಗ್ತಾವಲ್ಲ ಅಷ್ಟು ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಟೋಟಲ್ ಫೋರ್ಸ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ರಿ. ದಟ್ ಟೋಟಲ್ ಫೋರ್ಸ್ ಶುಡ್ ಬಿ ಈಕ್ವಲ್ಸ್ ಟು ಫೋರ್ಸ್ ಆನ್ ಎ ಕರೆಂಟ್ ಕ್ಯಾರಿಂಗ್ ಕಂಡಕ್ಟರ್. First tell me what is the force acting on single electron in a magnetic field. What is the force acting on single electron which is moving in a magnetic field? It is given by QVB sin theta. Q is nothing but charge. Q ಬದಲಾಗಿ ಏನು ತಗೋತೀನಿ ನಾನು E ಅಂತ ತಗೋತೀನಿ. What is E? Charge of electron. EVB sin theta. What is EVB sin theta? EVB sin theta is a force acting on single electron which is flowing in a conductor. What is V? V is a velocity with which free electron is moving in a conductor. What is V here? V is a velocity with which free electron which is moving in a conductor. From the knowledge of what? The current electricity, that velocity will call it as a Vd. What is Vd here? Drift velocity. Tell me what is F here? EVD B sin theta is a force acting on single free electron which is moving in a conductor. Then how many number of electrons are flowing in a conductor? The total number of electrons which are flowing in a conductor is given by capital N is equals to small n into volume of a conductor. Total free electrons in a conductor, I will call it as a capital N. That capital N is equals to small n into volume of a conductor. Then what is small n here? Small n we will call it as a free electron density. This small n is also called number of free electrons in a conductor per unit volume of a conductor. If n is number of free electrons per unit volume of a conductor, that multiplied by what? Volume of a conductor will give us total number of free electrons in a conductor. Then of course I will continue. The total number of free electrons in a conductor is given by capital N is equals to small n. Volume of a conductor is given by A into N. What is A here? Area of cross section of a conductor. What is N here? Length of a conductor. If A is area of cross section of a conductor and L is length of a conductor, then what is capital N here? Total free electrons in a conductor. Total free electrons in a conductor. Then what is the total force acting on all the electrons in a conductor? The total force acting on all the free electrons in a conductor is given by F is equals to n times force on single electron. What is the force on single electron? E Vd B sin. Okay. Then further, you know very well what is n here. F is equals to n. What is n? Small n A L E Vd B sin theta. What it is called? It is the total force acting on all free electrons which are moving in a conductor. It is also called force on current carrying conductor. The force on current carrying conductor in a magnetic field is given by N A L E V. Will you recall what is N A E V D? We discussed it in the current electricity. N A E V D is called current in a conductor in terms of drift velocity. N A E V D is nothing but what? Current in a conductor. Current in a conductor I is equals to what? N A E into V. Substitute. F equals to N A E V D can be written as what? It is I. L as it is. B as it is. 7. What this expression is called? ILB sin theta is a expression for force on current carrying conductor in the magnetic field. Where I is a current in a conductor, L is a length of a conductor, B is a what? Magnetic field at which conductor is placed, and theta is the angle made by orientation of the conductor. The angle made by length of a conductor with what? Direction of the magnetic field. So this is the expression for force acting on current carrying conductor placed in the magnetic field. Will you tell me when this force is maximum and when this force is minimum? The force is maximum when theta is equals to 90 degree. If theta equals to 90 degree, then what is sin theta? Sin 90 degree. What is the value of sin 90 degree? Sin 90 degree is what? 1. Therefore, the force is given by F is equals to IBL. This is called which force? The maximum force. Tell me when the force is maximum. Force is maximum when theta is equals to 90 degree. What is the meaning of theta is equals to 90 degree? Theta equals to 90 degree indicating that our current carrying conductor is perpendicular to direction of the magnetic field. If this current carrying conductor is placed perpendicular to the direction of the magnetic field, then the force acting is maximum. ಯಾವಾಗ force ಜಾಸ್ತಿ ಆಗಿರುತ್ತೆ ಹೇಳ್ರಿ? Suppose our current carrying conductor is placed perpendicular to the direction of the magnetic field, definitely the force acting is maximum. When the force is minimum or zero? When the force is minimum or zero? If theta is equals to 0 degree. If theta is equals to 0 degree, F is equals to what? ILB sin theta. What is theta? Theta is equals to 0 degree. Sin 0 degree is 0. Therefore, the force is 0. Force is 0 or minimum. When the force is 0 or minimum, the force is 0 or minimum when the conductor is placed parallel to the direction of the magnetic field. ಒಂದು ವೇಳೆ ಕಂಡಕ್ಟರ್ನ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ಗೆ ಪ್ಯಾರಲಲ್ ಅಲ್ಲಿ ಇಟ್ಟರೆ ಫೋರ್ಸ್ ಮಿನಿಮಮ್ ಇರುತ್ತೆ. Suppose conductor is placed perpendicular to the direction of the magnetic field, then the force is maximum. Many times for 2 marks this question has been, of course the derivation is important for 3 marks, but this question, that is when the force is maximum and when the force is minimum, this question repeatedly asked in the examination for 2 marks. When does force acting on current carrying conductor is maximum and minimum?